Helium is a necessary ingredient for lots of science happening at Ames National Laboratory. However, if you've been reading the news lately, you'll know that helium is one of the finite resources that the US government is struggling to source. It's expensive and it's hard to find.
I am Makari Tanatar. I am a scientist 3 in Ames Laboratory working in the complex stage at MWP with Ruslan Prozorov and the colleagues. And I am supervising Clayton Swenson low temperature laboratory. Because helium always have to be kept contained, not released to the atmosphere, low temperature laboratory is collecting helium after boiling off from experiments, retains it and makes liquid helium again.
Absolute zero represents the lowest possible energy in a system and the least amount of thermal motion. Helium has one of the lowest possible melting temperatures, is safe to work with, and having it in a liquid form makes it ideal to cool things. It can cool systems down to temperatures where quantum effects are most pronounced. That allows researchers to probe quantum behaviors of materials, particularly those with competing quantum properties such as magnetism and superconductivity.
Because of that, because thermal motion is proportional to absolute temperature, cooling to liquid helium provides opportunity to study quantum effects which otherwise are masked by thermal fluctuations.
I'm Fred Perra. I'm a staff scientist here at Ames Lab, and I lead the Nuclear Magnetic Resonance Spectroscopy Laboratory. So for nuclear magnetic resonance spectroscopy, we need to use a lot of high-powered magnets, such as the one behind us. And these superconducting magnets contain a coil of superconducting wire that needs to be housed in a bath of liquid helium in order to work. And so in all, the magnets that are housed in this room end up using roughly 1,200 liters of liquid helium every year, which is enough to fill on the order of 100,000 helium balloons. And so given the fact that helium is such a scarce resource, being able to recycle this helium locally and keep the costs down is really enabling for our science and being able to keep all these magnets alive.
Let's try to follow what path helium molecule travels in the Ames laboratory. Once I want to do experiment, I will take Dewar from the north wall of the low temperature laboratory and will bring it to the lab. In the lab, I will connect helium to recovery system to remove boil off which formed during movement. Then I will connect it to my experimental setup, make helium transfer, and during transfer, boil off of helium is collected by recovery system. This recovery system passes helium through flow meter, which enables me to see how much helium I am losing, and then it travels to helium storage bag. This is an endpoint for experimentalist. From this point, gas compressor pumps helium out of helium bag into storage. This storage has two parts. One part is storage in the Zaffarana physics basement, and another part are two big cylinders outside of the Zaffarana building. Here it is stored temporarily until low temperature lab has enough gas and enough demand from the customers to produce liquid helium. At this point, gas from storage is pumped by the liquefier, by compressor running liquefier, and is transformed again into the liquid, and then it goes into the Dewar, and this Dewar is ended up at the north wall of the Zaffarana physics hall, so ending the cycle.
Helium from the low Temp Lab is used all over Ames Lab and the Iowa State University campus in 7 different buildings. This research influences many fields of science, engineering, health, and industry. Liquid helium makes discovery possible.